Guys, are you guys okay? You guys had a good weekend? Right, starting today until the end of next week, we're going to do revision to prepare you guys for the final exam, which is exactly 3 weeks from now, on the 23rd. Exactly 3 weeks from today. 23rd is of May, which is a Tuesday. Right? So, if you have, I'm hoping you guys have lots of questions to ask me, so you can keep me busy writing things on the board. So, could you please fire away with the first question? I've got all the past exam papers, and I've got all the past in-class tests. So you should tell me a question. I'm happy to do that. So you see, I've brought with me the copies of all the past exam papers and the past in-class tests. So tell me, guys, please. Any question you like me to do now? Yes, no? It should be here, God. Yeah, it should. Any questions you like me to do? Don't be shy. It seems all of you know everything. It seems all of you know everything. So maybe there's no need for the exam. All right. One thing I found in the. By the way, with the in-class test. I gave you feedback already, right? Did you find my feedback useful? The general feedback I gave? Question 1, many people had problems with integration. Not many, the guys who didn't do, there were like 50 plus people who got 20 out of 20. That's a very high proportion, guys. 50, well, I think there were 51 students got 20. And there were, that's a very high proportion, but it won't be like that. The exam will be a lot, it's not straightforward, guys. So you have to work very hard for the exam, right? I mean it. I'm not just kidding, guys. I'm just saying the exam is usually not it's of higher level than the in-class test, at least in recent years, right? So please try to work. You have to work even if you got 20 out of 20. Still, you need to work harder for the exam, right? Okay. Now, question 1, as I said, question 1, first part. The first part was to find the CDF of the Gumbel distribution. So, to find the CDF, some people don't know the formula is. Some people don't know. Like those of you who didn't do it correctly. I'm not talking for everybody. I'm talking for the people who did not do part 1 correctly, right? The formula that you should use is, this is the formula you should use, where this guy is the PDF, density function of the distribution. Oh, what happened? Can you see anything here? Oh, God knows what happened. Oh, let me see. Oh. Okay, now it's okay. Right. All right. Now, this is the correct formula to use to find the CDF, right? So it's the integral from minus infinity to x of the PDF, right? And some people had the limits as minus infinity to plus infinity, which is not the correct thing. Yeah? You guess okay? And so that's part one. Part two was to find the moment generating function. To find the moment generating function, you just integrate. I'm getting really annoyed with this. Sorry, guys. It's not my fault. I can't do anything. Maybe this one. Can you see this, guys, from the back? Yes? Okay. For this is the formula to use for part 3, right? Sorry, part 2. I mean, the MGF of the Gumbel distribution, right? You can simplify it. For part 3, you are asked to find the expected value of x, right? Some of you did is the following. Let me show you. Some of you did this, but this is actually a waste of time. I know some of you got this right, but if you are doing this to find the expectation, then you are wasting a lot of time, right? The quick way to find the expectation is to differentiate the MGF and put t equal to 0. Yeah? This is the quick way to find the MGF. The only problem is that if I use this, then this will not be recorded on the podcast. You see? That's why I'm trying to sort this out. Anyway, all right. So this is the shorter way to do it. I think in an exam in the future, please try to use this approach, because you don't, especially in the exam, you don't want to waste time. You don't want to waste unnecessary time, right? Okay. So please use this approach, not this. This will take you a lot longer to do this like this, right? So that was question 1, guys. Now, question 2 was okay. I think generally people did better. Generally, people did better in question 2 than question 1. Question 2, but part 1 was to find the likelihood function of theta, which is basically the product of theta 1 minus theta, yeah, like this. And I think I mentioned this many times in the past, right? Some of you, maybe not, none of you here, maybe, I don't know who the people were, but some students were not able to simplify this correctly. I cannot emphasize this enough times, because I found quite a few people who were not able to simplify this correctly, right? Because if you mess this up, then everything else also messed up, right? So therefore, it's very. I think if you look at if you go to the website. If you go to the statistical methods website, there's a link. There's a link called elementary. There's a link in the course website called Elementary Mathematics, right? If you click on this link, it gives you various identities. Are you listening to me, guys? If you click on this link, it gives you various identities that help you to simplify likelihood functions, right? So if you have difficulties simplifying likelihood function, please go to this link and learn those identities, right? Because as I said many times, this is very, very, very important. If you mess this up, that's it. Then you get the whole question wrong. Okay. Okay. All right. So that's the main thing I want to say about question 2. Right. I think part 2 was okay. Part 3. One other thing. Yeah. Part 2. In part 2, the MLE for theta was 1 divided by x bar. Then in part 3, you were asked to find the MLE for psi, which is 1 over theta. And a lot of people, what they did is to rewrite the likelihood in terms of psi and find the MLE. I think that's once again a waste of time. I mean, you're wasting a lot of time if you want to rewrite. I mean, if you want to find the MLE for psi by rewriting the likelihood and taking the log, taking the derivative, and setting it to 0, and finding the MLE, and making sure that the second derivative is negative, that's lots and lots of work, guys. You don't want to do that. I mean, what you should say in this case is that because this is equal to this, the MLE for psi is simply 1 divided by the MLE for theta, which is 1 divided by x bar, which is x bar. So this is the way you should answer, because it saves you just lots and lots of time. Yeah? You know what I'm saying? Yeah? Because time is very crucial, especially in the final exam. Okay? You don't want to spend doing things taking unnecessary time. Okay? Right, that's part 3. Part 4 was about the bias and the MSC. I think most of you got that right. Part 5 was also okay. I think if you got the bias and the MSC wrong, then part 5 was also wrong. Okay. Any questions you like to ask, guys, on the in-class test? Because I think the majority of the class did very well. the average was too high, I guess. I thought it was too high. Hi. You mean this one?
Yeah. If you just do that. Oh, it should. There's like a, can you see? There's like a little mark on the underside of it. That's marked it. And it's focusing on that. So it should.
I don't know why, because
But now focus. Have I got the wrong one, or is it the right one?
oh,
Yeah, I'm not sure. I thought it was a.
I think I need to call the guys.
Yeah.
Yeah, it's all right. All right, guys. I thought you guys have lots of questions, guys. Can you think of a question for me in a minute? Guys, please listen. This is in-class test 2008-9. Trying to fish out. All right, here we are. All right. This is you have X has the Laplace distribution with this PDF. Can you see this, guys, from the bottom? No? Anyway, this is the PDF of the Laplace, and we want to find the MGF of it, right? So let me do it over here until the guy comes. So this is test 2008-9, question 1, part 3. And you're given this PDF. Hi. This is not focusing, sir. This is on display. Is it good? Okay. Okay. Okay, thank you. All right, hopefully this will. So this is the PDF from minus infinity to plus infinity. And the question is to find the MGF of it, right? So we want to find the corresponding moment generating function. So what you have to do, guys, is all right, the exponential function e of tx times the PDF. This is the PDF from minus to plus infinity. Now this is a constant, so you can pull it outside the integral sign. So this will become 1 over 2b all right? Okay. Now, any ideas on how to integrate this? Now, remember, whenever you have, I know you guys probably done more math than I have. Whenever you have an absolute sign like this, the first thing you must do, the first thing you should try to do, is to remove that absolute sign. Yeah. Now, do you see why I have done this? I have split the integral from minus to plus infinity into two different integrals. The first integral is from minus infinity to a. The second integral is from a to plus infinity. Now, let me ask you, let's take the first integral. So over the integral from minus infinity to a, what would this be equal to? The absolute value of x minus a over this interval will be a minus x. Do you guys see that or no? Yeah? Yes? All right, now let's take the second integral from a to plus infinity. Over this integral, over the integral from a to plus infinity, the absolute sign of x minus a will be x minus a. So you see what I've done? Every time, whenever you see an absolute sign, it's a good idea to split it's a good idea to split the integral into two regions, right, where you can find the exact value of the absolute sign. So here I have split like this, okay. Now I'm going to take out the constants. Right? So I've taken these two constants outside the integrals, sorry, outside the integrals, yes. Right, so you get this and this. Right, now integration of this one And the integration of this one is not hard. Okay. So the integral of this is simply this. Take the limits from minus infinity to a, and the integral of this is, oh sorry, okay, sorry, it should be like this. Right? Oh yeah. So let me put this over here, guys. All right. Next, taking the limits. Now, when I take the limits, I'm going to assume certain things. I will tell you that in a minute. Right? When I take the limits at a, it's going to become a plus 1 over, sorry, t. Right? This is what I will get if I take the limits. All right, for the first one. For the second one, it will be 0. Okay. This is what you will get. You should take the limits for the second one. All right? Yeah? And then it's a matter of simplification. You should simplify this. You will get the result. You should simplify this a little bit. Let me see how it simplifies. It will simplify to something like this. And then you should take the common factor, which is t squared minus 1 over b squared. You get times 2 oh, there should be a minus sign here, guys, sorry. This is not plus, this should be a negative sign. So it should be minus okay, so this will be the 2 and the 2 will cancel. So I think the answer will be Yeah. So I think this will be the answer. Correct me if I'm wrong, but after some algebra, this is what you should get, I think, for the MGF of this distribution here, right? You mean this one? Yeah, and you put, so I'm, that's what I was going to say, guys. I'm going to assume, I was assuming throughout that t, or t minus 1 over b, sorry, t minus 1 over b is a negative number, right? Otherwise, you cannot say that when you put plus infinity, right, this will disappear to 0 only if this number is a negative number. And similarly, I was assuming that t plus 1 over b is a positive number. So these two conditions are needed. These two conditions are needed for these two integrals to converge, right? So it doesn't say in the question, but in the, because this was an in-class test, I did not specify the conditions, but in the exam you will be specified the conditions, right? Yeah. So these two conditions must hold for the two integrals to converge, right? Yeah. Is this clear, guys, or not? I mean, this is just mathematics, guys. It's not. It's just simplification of integrals. So I know you must know this kind of stuff, but yes. Any other questions, guys? Any other questions you'd like me to do? So this was 2008-9, question 1. There was a question I started before the Easter break, but I forgot to finish. You see, my memory, I have a very bad memory, so thank you for reminding me the question. This was a question I started doing. You have x1, x2, trying to remember which, is it up to x20, which one? Let me see. This one. Is example 88. Right? So this is a question I started doing before the Easter break, but I completely forgot. All right. Now, remember, when the question says, find the most powerful test, what it implies is that use the Neiman-Pearson lemma, right, to find the test. So the first thing you must say by you must say by the Neiman-Pearson lemma, we reject the null hypothesis if the likelihood at point 2 divided by the likelihood at point 3 is less than a constant c. All right. Now, let me ask you, what's the likelihood at point 2, guys? We have we have 20 observations from a Bernoulli distribution. What is the probability mass function of the Bernoulli? Do you guys recall? Yes? No? Come on, guys. This is something I gave you long time ago. You probably forgot. This, what I have written here, this is the probability mass function of a Bernoulli distribution, right? Right, and with parameter 0.2. All right? You with me, guys? Yes, no? Yeah? Okay. Now, if you simplify this, you get you guys follow this step? Yeah? Is it a big jump or is it a small jump? It's just simplification of this. It leads to this, right? I mean, it's yeah. Now, 0.2 divided by 3 is just simply 2 divided by 3 power sum of xi, I from 1 to 20. Yeah, and 1 minus 0.2 divided by 1 minus 0.3 is 8 divided by 7. Now this guy here, you can yes? Okay. Now I'm going to combine the second part. I'm doing it slowly because I know you guys will ask me questions if I do it fast. So I don't want to do it fast, guys. Just for your benefit, guys, I'm doing it in slow steps. Yeah, this will become this. Yeah. And now I'm going to combine these two terms. So this will be 14 divided by 24. Yeah. Do you see how I got 14 and 24? Yes. Because 7, because there's a minus sign here, you're going to switch this around. So 7 times 2, 14, 8 times 3, 24, right? Okay. Now, we're not done yet. 14 divided by 24 is 7 divided by 12, right? Yeah. It's less than now. The next step, I'm going to. All right, let me throw this away. Put this over here. In the next step, I'm going to take the log both sides. So if I take the log on the left-hand side, okay, this is what you get if you take the log. Now, in the next step, I'm going to divide both sides by this guy here. Now, before you divide an inequality, you must know the sign of the factor that you're dividing by. Now, we are dividing by this factor. Now, is this factor positive or negative? Come on, guys. Is it positive or negative, guys? It's negative, right? Because 7 by 12 is less than 1. So log of anything less than 1 is negative, right? So the sign will change from less than to greater than, right? Okay? So now for the sake of convenience, let me call this K. Right? So the story so far is that by the NP lemma, we reject H0 if the sum is less than a constant K. Is this clear, or it seems some of you are not clear? I sure this is clear to all of you. Yeah. Now the second part is to, well, there's only one question, but to find the value for K. Now, how do we determine the value for K? Now to do that, you are given alpha is 0.05, right? Alpha, remember, is the probability of type 1 error. Probability of type 1 error is equal to 0.05. Now this is the probability of rejecting, that is given that p equal to 0.2 is equal to 0.05. Now this is where your probability 1, I guess, probability, what distribution does this have? we are told that xi are Bernoulli random, independent Bernoulli random variables. So sum of xi should have, come on guys, sum of Bernoulli is equal to sum of Bernoulli is equal to the binomial. Remember, I'm sure you've seen that before, right? Yeah. So this is the equation we have, and this equation can be solved numerically for the value for k. So if you are familiar with R, for example, you can use that commands in R to solve this equation for k. All right, guys. We got another example class from 5 to 6. For more questions, please come to that example class. I mean, all the example classes this week and next week are going to be revision classes. So feel free to come to any of the example classes. All right? Guys, your exam paper, your test paper is over here. If you haven't collected it, hello? If you haven't collected your test paper, could you please come forward and collect yours? Oh, yeah, yeah. Sorry. Sorry, ma'am. Sorry. Sorry. Yeah, you gave it to me last week, right? Yeah, yeah. Sorry. I put it here. Oh. It's this one, right? Is it this one? Yeah. Thank you. Thank you. Yeah.